Hello everyone, welcome back to the channel Mining Engineering. Today's topic Geographic Information System, lecture number 6. Let's have a quick recap. GIS data model, and in this model we have represented the real world as per the raster representation. As you have known, this is the river and we have this cells were used, like this blue cells are used for representing the river, and these green cells are used for representing the forest area, and this yellow pixel or cell is used for representing the house of the real world as per the raster representation. Now let's see how to represent the same real world as per the vector representation. Vector data model. Vector model represents the area of interest as a combination of primitive spatial data objects. These primitive spatial data objects are points, lines, and polygons which are located by a pair of XY coordinates in a spatial reference frame. As you can see, this is the river, and we have used up to this point, we have used the line for representing the river, and this area, this water body is the polygon is used for representing this water body, and again for this river the line is used, and for representing the trees we have used 3 dot with xy value. Traditional vector data model stores the spatial and attribute information separately in a graphics file and relational database respectively. This is a graphic file, and the relational database is the attribute table for that graphic file. The spatial information and attribute information for these models are linked by a simple identification number that is given to each features in a map. Points as 0 dimension has the property of location, represented by one or more pair of xy coordinates. Other point features node or vertex. The point id is given 1, x coordinate and y coordinate is 3 and 3. For line, it is one dimension, has the property of length. Two endpoints are required to represent a simple line feature. There can be more points in between these two. Can be called edge, arc, link, or chain. And this is for the line representation. And this is the attribute table for that representation. The next one is polygon. Its 2 dimension, has the property of area and perimeter. Can be defined with the set of coordinates of arc or line which represents the complete loop. Can be called area or zone. This is for the polygon representation, and this is the ID and the coordinate system for the attribute table. Zooming on raster and vector data, you can visualize these two representation of the map and can see which map represents more accurately as compared to the other. Let's see the video. You can see the zooming. Due to the raster file, the data are stored in each cell. So after zooming, the cell pixels are getting blurred. However, in the vector data representation, as the data are stored in a point, line, or polygon, so one point, after zooming that point, it converts into line or polygon, and the visualization is more accurate. Representation problem. Some geographical phenomenon can have different represents at different scales and with different levels of accuracy. For example, here is a river as a line, the town as a polygon, and here is the thing. And after zooming, we can see there is a river and the pond and one church, and then zooming the church, pond, and the church hall. So this is the thing. Same geographical phenomenon can have different representation at different scales and with different levels of accuracy.